So in this question, we're given that g of x is 2x plus 5 over x minus 3. And we're given the domain for this function, which is that x is greater than or equal to 5. And we need to find out what g of 5 is. Now an easier way to write g of 5 is if I write in this notation here, where g square brackets g of 5. And now what we can see is that what we're really doing is that we're finding out what g of 5 is by plugging 5 into this function, using that answer and plugging it back into g, and that will give us g of 5. So let's start by finding what g of 5 is. So g of 5 is simply going to be the function g that we have here, but we'll have 5 in replacement for the x. So we'll have 2 times 5 plus 5 over 5 minus 3. And I put the brackets around the 5 so you can clearly see the substitution that I made for the x's into the 5. Now simplifying this, we'll have 10 plus 5 over 2, which is 15 over 2. Now remember, we're finding g of 5. But if g of 5 is 15 over 2, then now what we're really finding is g of 15 over 2, which is the same as g of 5. Now putting this back into the function, we'll have 2 times 15 over 2 plus 5 over 15 over 2 minus 3. Simplifying this, we'll have 15 plus 5 at the top, all over 15 minus 3, which is 9 over 2. Simplifying this, we'll have 20 over 9 over 2, which is 40 over 9, as I've times top and bottom here by 2. And that is our final answer for this question. Now, the breakdown for marks here is you would get 1 mark for finding what g of 5 is, which we've done here, and you'll get 1 mark for the final answer, and that will give you the 2 marks in the question. Now, for the second part here, we need to find out we need to state the range of g. So the first thing we shall do is look at the domain of the function they've given us, which is that x is equal to or greater than 5. Well, let's see, we know what g of 5 is from the previous question. It was 15 over 2. So now we need to find out whether this is going to be the maximum of g of x or the minimum of g of x. Now, a way to investigate this is, let's see what happens to x as it gets very, very large. So if we take the limit as x approaches infinity of g of x, which is the same as the limit as x approaches infinity of 2x plus 5 over x minus 3. Now when x is very, very large, then these bits here, the plus 5 and the minus 3, become so negligible to the actual value, to the point where we could ignore them. So now we'll find a limit as x approaches infinity over 2x over x. And here we can see we can simplify this fraction by crossing out the x's, and we can see that our final limit here is just going to be 2. So now we have two cases where when x is the lowest possible value can be, i.e. 5, g of 5, we have it's 15 over 2. And when x approaches infinity, the function approaches 2. So these must be our two bounds for g of x. So that g of x must lie in between 2 and 15 over 2. And now we need to check something. Can g of x ever be 15 over 2? Well, yes, it can, because x can be 5, therefore g of x can be 15 over 2, which means this must be a less than or equal to symbol. Now, can g of x ever be 2? Well, this is where our limits come in. As x can never actually be infinity, x can only approach infinity, which means this function approaches 2, but never actually gets to 2. Therefore, that must mean that g of x must be greater than 2, but never equal to 2. So this is a final answer, which will get you the 1 mark. For part C of this question, we need to find the inverse of g of x and also state its domain. Let's start by the first part, which is finding the inverse of g of x. Essentially, we have that g of x is 2x plus 5 over x minus 3, and we're trying to find the inverse of this. Now, the best way to go about this is replace our g of x with a y and keep the function the same. Then what we want to do is make x the subject of this equation. When we find x as the subject of this equation, we'll have the inverse of g of x. Because that's essentially what we're doing, you're flipping the x's and the y's. So now, let's times both sides by x minus 3 to simplify this. So you have y times x minus 3 equals 2x plus 5. Then let's expand the bracket on the left-hand side. So we have xy minus 3y equals 2x plus 5. Now, because we're trying to make x a subject of this formula, we want all the x's to be on one side and the y's and the constants to be on the other. So let's add 3y to both sides and take away 2x from both sides. So we have xy minus 2x equals 3y plus 5. And now I'm going to factorize the x on the left-hand side to get it by itself. So taking x out of both these, we have y minus 2 times x equals 3y plus 5. And now I can simply divide both sides by y minus 2. So we'll have 3y plus 5 all over y minus 2. Now substituting the correct formula symbols back in, x now becomes the inverse, which is g to the minus 1 of x. On the right hand side, we'll have 3x plus 5 over x minus 2. And that gives you the inverse function right there. But now the next part is that we need to find the domain of this function. Well, the domain of the inverse is simply the range of the original function, which means that from part B, where we calculated the range of the first function, this is actually also the domain of the inverse. And all we have to do is replace the g of x with an x. And this will be the domain of the function g to the minus 1 of x. Now the breakdown of marks, you'll get 1 mark for setting the correct domain, 1 mark for finding the inverse, and 1 mark to getting the stage here. So this question is about vectors. Let's read and see what's going on. Relative to a fixed origin O, the position A has position vector 2y plus 3j minus 4k. The point B has position vector 4i minus 2j plus 3k. And finally, the point C has position vector ai plus 5j minus 2k, and we know that a is a constant and it's negative, which might come in handy later. Finally, D is a position vector such that to get from A to B is the same thing as going from B to D. Now we need to find the position vector of D. Now the first thing we can do is utilize this information that A to B is B to D, as this is the only knowledge that we have of what D could be. Well, we need to find out what AB is. Let me show you a quick diagram that might help visualize this. Suppose this is the point O, the origin. This is position vector A, and this is position vector B. And we need to get from A to B, where that is AB. Well, we can see that this could also be expressed as going from A to O, and then going from O to B. Now, using this information, we can see that AB is the exact same thing as AO to OB. Now we need to find out what AO is. Well, AO is simply the reverse of the position vector A. As you go from O to A, you'll have the position vector A. As you go from A to O, you'll have the position vector to the reverse of A. So let's write this in column vector form, as it's quite easy to see. Now let's go back and see what A is. A is 2i plus 3j minus 4k. So I'll have minus 2i minus 3j plus 4k. Next we have position vector B, which OB is just B. So we'll have 4i minus 2j plus 3k. Now adding these together, we'll find out what AB is. So minus 2 plus 4 will give us 2. Minus 3 minus 2 will give us minus 5. And 4 plus 3 will give 7. And that's what AB is. But we know this is the same thing as BD. And now we need to work out what BD is. Well, using a similar diagram as before, we can visualize what it could be. There's O, there's B, and there's D. Let's get from B to D. It's the same thing as going from B to O, and then O to D. And we're trying to figure out what O to D is. So if we know that BD is BO plus OD, then we can rearrange this. So we have OD is the same thing as B to D minus B to O. And because we know B to D is the same as AB, we can replace that in. And now we're ready to form a vector equation and solve it. So writing this column vector form, A to B is 2 minus 5, 7, which we have got from here. And then we have minus BO. Well, as I said before, BO is the same thing as the reverse of O to B. If O to B is 4 minus 2, 3, as seen here, then we must know that this must be minus 4, 2, minus 3. Add these all together. 2 minus minus 4 is 2 plus 4, which is 6. Minus 5 minus 2 is minus 7. And 7 minus minus 3 is 7 plus 3, so we have 10. And this is our final answer for D is. In terms of the marks for this question, you'll get 1 mark for finding what D is, and you'll get 1 mark for finding what BD is or AB is, for a total of 2 marks. So now that we're done with pi, let's move on to part B. So in part B, we're given that the modulus of AC is equal to 4, and so we need to find the value of A. Well, let's first start by using the information in the question, and we'll try and work out what AC is. Well, to help us work out what AC is, let's draw a quick diagram. Suppose this is your origin O, and this is A, and that this is C. We want to get from A to C like that, and that's a vector AC. Well, alternatively, we can write this as going from A to O, and then going from O to C. Which means AC, we can rewrite as the same thing as A to O to C. And now all that's left is we need to find out what these two are. So what's AO? Well, if OA is the position vector A, to get from O to A, that means that AO must be the reverse of position vector A. Which is that from the question, if A is 2i plus 3j minus 4k, then that means that AO is going to be minus 2i minus 3j plus 4k. And OC is just the position vector C, which is given in the question as AI plus 5j minus 2k. We have AI plus 5j minus 2k. And adding these vectors up, we'll get what AC is. So minus 2 plus A, I can write that as A minus 2. Minus 3 plus 5 is just 2. And 4 plus minus 2 is also just 2. But the question here asks us that we need to find out the modulus of AC. Well, how do we find out the modulus of AC? Well, we're going to use the triple Pythagorean theorem. Let me draw a quick diagram to help explain what that really is. Suppose this is our y-axis, this is our x-axis, and this is our z-axis. You can think of this of I, J's, and K's as well if you'd like. I suppose this is our position vector A, and there's C, and we want to find out what the distance AC is. Well, I'm going to draw a line down from C to there, to a point called M. And we're going to let M have the same x coordinate and z coordinate as C, but it'll have the same y coordinate as A, which means this line here connecting A to M, I'll label that as A to M. And that this distance here, from M to C, is going to be, let's call it YAC, the difference in the y coordinate from A to C. Now if we draw a line from the x-axis up to M, well, you can see that this line here, the one that I've just drawn, is parallel with the z-axis, and is the movement from A to C, but in the z plane, which means this must mean this is ZAC. And finally, we can draw a line from the z-axis to M, which is parallel with the x-axis. I'm going to draw right angles here to show that they're perpendicular to that one and parallel to the other. So this line I've drawn in here is parallel with the x-axis, and it takes you from A to C in the x-plane, which means that this must mean this is XAC. And we also know that this right here is another right angle, as it's going from the z and x plane to the y plane, as they're all perpendicular to each other. Now we need to find out what AC is. And we can do this by first looking at this triangle here. Now if you recall that the Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse and a and b are the two shorter sides. And we can use this formula on the triangle we've just drawn. So saying c is our AC, we have AC squared is going to be the two shorter sides added together, which in this triangle here is going to be this AM and this YAC. So this is going to be AM squared plus YAC squared. And now we just need to find out what AM squared is. And we can do this by looking at another triangle, which is this one here. Applying the Pythagorean theorem to this triangle, we can see that AM is going to be our C squared. And that's going to equal the two shorter sides. Now we know one of them is going to be xac squared, as shown there. But what's this one here? Well, we can look at that distance here is the same as ZAC, which means if we wanted to, we could also label this as ZAC. So our other shorter side is going to be plus ZAC squared. And now, using this AM squared, we can put it into the above formula here. So now we're going to have xac squared plus ZAC squared plus YAC squared is going to equal the modulus of AC squared. And that is our triple Pythagorean theorem for vectors. Now, we just need to work out what each of these is. Well, we've worked it out from the previous question. As these are all the difference in distances between AC, A and C, the position vectors, sorry, that means that that's just going to be AC. So our x1 is going to be our I, which is going to be our A minus 2. So we can write this as A minus 2 squared. Our Z is going to be our 2, our also known as our K, so that's going to be 2 squared. And our Y is going to be the other 2 squared. And that's going to equal our AC squared. Now, we know what AC is from the top of the question. It's given there, it's 4, which means that AC squared must make it 16. So simplifying this, we'll write this as A minus 2 all squared, plus 2 squared, which is 4, plus another 2 squared, which is 4, plus AC squared, which is 16. And now taking away 16 from both sides and rearranging, I'm also going to write the A minus 2 squared as A minus 2 times A minus 2 to make expanding slightly easier later on. So we're going to have A minus 2 times A minus 2 plus 8 minus 16 equals 0. Now I'm going to expand out the A minus 2 squared and also simplify the A minus 16 as well. So first we'll have A times A, which will give us A squared. Then we'll have A times minus 2, which is going to be minus 2A. Then a minus 2 times A, which is minus 2A. And we'll have a minus 2 times a minus 2, which will give us a plus 4. Now plus 18 minus 16 will give us a minus 8. And that equals 0. Simplifying this further, collecting the A's, we have A squared minus 4A. 4 minus A, which is minus 4, equals 0. Now we've landed in a quadratic in A. And we can just solve this by completing the square. So adding 4 to both sides, we have A squared minus 4A equals 4. Completing the square on the left-hand side, we'll have A. Half this coefficient, so we'll have A minus 2 squared minus 2 squared equals 4. Adding 2 squared to both sides, we'll have A minus 2 squared equals 4 plus 4, which will give us 8. And now to simplify and find out what A is, we can square root both sides, we'll have A minus 2. Careful here, plus or minus the square root of 8, as it could be either solution. Then we're going to add 2 to both sides, and we'll have A equals 2 plus or minus the square root of 8. Now the question becomes, is our answer 2 plus the square root of A or 2 minus the square root of A? Well, to find out what the answer really is, we can refer back to the question. And if you notice, it says here that A is a constant and it's below 0. Therefore, we have to use the negative solution here, which means that A is going to be 2 minus the square root of A. And finally, we're going to simplify our answer as the square root of A is the same thing as the square root of 4 times 2. Bringing the square root of 4 out, which is just 2, is the same thing as 2 root 2. So finally, our answer will be A, which equals 2 minus 2 root 2. And that's our final answer. In terms of the marking for this question, I'll get 1 mark for the final answer, 1 mark for getting to this quadratic, and 1 mark for finding out what AC is at the top of the question, there, for a total of 3 marks. So let's read this question and see what's going on. If m and n are irrational numbers where m does not equal n, then m and times n is also irrational. And we have to disprove this statement by means of a counterexample. We'll start off, let's first discuss what is an irrational number. Well, a rational number is anything that cannot be expressed as a fraction. For example, 22 over 7 is a fraction, therefore it is rational. Or the number 4 can be expressed as 4 over 1, therefore it's not irrational. Or even the number 2.5 can be expressed as 5 over 2, therefore it's not irrational. So examples of irrational numbers would be something like pi, as it can't be expressed as a fraction. Same with e, as it cannot be expressed with a fraction. And any surd you could like, so root 2, root 3, all surds are also irrational numbers as they cannot be expressed as a fraction. So we need to come up with 2 numbers that when multiplied together give a rational number, as that will be the counterexample that we need to disprove this statement. Now we could use pi and e as our rational numbers, but the issue with using pi and e is that often they give irrational numbers, or they give numbers that are almost impossible to prove whether they're irrational or rational. So we might want to use surds here. So in terms of surds, we would like it so we have the square root of one number, say x, times square root of another number, say times square root of y, will give us square root of z, where z can be simplified down to just a constant a. Now for this to be the case, that means z must be a square number. So the square numbers we have, well, we could use 1, but that won't work, because then we'll have root 1 times root 1, and that can't happen because m and m can't equal each other, and they're both rational numbers. The square root of 1 is 1. We could use 4, but the issue with 4 is that we'll have root 2 times root 2, and that means that m and n are the same number, even though they're both irrational. We could have z equal 9, but the issue with 9 is we'll have root 3 times root 3, which means that they're the same number, which can't happen, as shown in the question. Or we'll have root 9 times root 1, but neither of which are irrational numbers. Now we could have 16. Now with the factors of 16 we have are 16 and 1. We can't use that because both root 16 and root 1 are rational numbers, as root 16 is 4 and root 1 is 1. So we could use 8 and 2. Now this works because both the square root of 8 and the square root of 2 are rational, as the square root of 8 can be simplified down to the square root of 4 times 2. Taking the root 4 out is 2 root 2. So now we can let x equal the square root of 8 and y equal the square root of 2. So we have the square root of 8 times square root of 2, multiplying the insides of both of these, 8 times 2, square root of 16, and the square root of 16 is just 4, which is a rational number. And therefore we've disproved the statement by means of counterexample. But we're not done there yet, as this will just get us 1 mark. For the second mark, we need to write a sentence to conclude. So we can say, therefore, the statement has shown to be false by means of counterexample. And notice how in this wording here, I'm using almost similar wording to what's given in the question. Now for the marking points, you'll get 1 mark for your conclusion, and you'll get 1 mark for finding a solution, finding two irrational numbers that when multiplied give a rational number, and that'll give you the 2 marks for this question. So now that we're done with part A, let's move on to part B. So we need to sketch the graph of y equals mod of x plus 3. So what does the modulus function mean? Let's discuss that first. Essentially, the modulus function will take any negative number and turn it positive, but keep the same value. For example, it will turn the modulus of minus 2 into just 2. And for positive numbers, let's say the modulus of 3, it'll just stay as 3. So the modulus function takes any negative number and turns it positive, but keeps the same magnitude. And for positive numbers, it does nothing. Now that we know that, we can get on with sketching the graph. So there's my y-axis, and there's our x-axis. Now we need to sketch y equals mod of x plus 3, but what might actually be easier is let's sketch y of x plus 3 first. And we'll see why this is easier in a second. So when y is 0, x must be minus 3, so we'll have a point there. And when x is 0, y is 3, so we'll have a point there. And we know that this must mean that this is a straight line connecting these 2 points, as it follows the y equals mx plus c straight line equation, and there's no power of the x, so it must be linear. Now let's investigate what happens with y equals mod of x plus 3. Well, when x is minus 1, we get y equals 1 plus 3, which is 4. But this is the same thing as when x is just 1. 1 plus 3 is just 4. And this will be the same for any negative for minus 2, minus 3, minus 4, etc. So what this must mean is that whenever x is negative, it has the same y value as when x is just positive, the same magnitude. Which means that this must mean that the graph of y equals mod of x plus 3 is a reflection in the y-axis. So that right there is going to be the graph of y of mod of x plus 3. Now we've done that, we can move on to the second part of the question. So we need to explain why mod of x plus 3 is greater than all of mod of x plus 3 for all real values of x. Now we can largely ignore this second highlighted part here, as this is just discussing imaginary numbers, which we don't need to know. We're more focused on the inequality here. Now what might be useful is to sketch the graph of y equals mod of x plus 3. So, the graph of y equals mod of x plus 3, well, right away we can see that y can never be negative, as whenever the inside of this becomes negative, the modulus function will spit out a positive number. For example, when x equals minus 4, we have y equals minus 4 plus 3, which is just minus 1, well, modulus minus 1, which is 1. So y can never be negative, which is the lowest point of y is when x equals minus 3, i.e. this point here. So this graph must follow the graph of y equals x plus 3, like that, but then reflect itself back up when y becomes 0, as y can never be negative. And that's the graph of y equals mod of x plus 3. Now we need to show why this is lower or equal to the graph of y equals mod of x plus 3. Well, we can see that in this region here, when x is below 0, so there's the origin, and x is below 0, that we can see that the graph of y equals mod of x plus 3 is always going to be lower, this line is lower, than the graph of y equals mod of x plus 3, as all of this bit here is lower than this bit here for this whole region. So we can say that when x is below 0, the graph of mod of x plus 3 is below the graph of mod of x plus 3. But let's find out what happens when x is greater than or equal to 0. When x is equal to 0, the graphs share the same point. But also whenever x is positive, the graphs also share the same points, which means that when x is equal to or above 0, the graph of mod of x plus 3 equals the graph of mod of x plus 3. So combining these two together, we can say that overall, the graph, well, the function mod of x plus 3 is lower than and sometimes equal to the graph of mod of x plus 3. And that right there is our final conclusion. In terms of the marking for this question, we'll get 1 mark for this conclusion. We'll get 1 mark for sketching these two graphs, for a total of 3 marks for this question. So this question is about series, so let's read and see what's going on. We need to show that the sum, which is what this big Greek letter sigma stands for, the sum of r equals 1 to 16 of 3 plus 5r plus 2 to the power of r equals 131,798. The first thing we're going to do is let's split up the sum into its 3 constituent parts to make it a lot easier to deal with. So first we'll have the sum from r equals 1 to 16 of 3 plus the sum of r equals 1 to 16 of 5r plus the sum of r equals 1 to 16 of 2 to the power of r. It's the exact same sum as we have here, but we've just split up into 3 different parts. And now let's write out these sums to see if we can get an idea of what's going on. Now this first part here, there's no r in the brackets. So all we're doing here is just summing 3 a total of 16 times. So we'll have 3 plus 3, so forth, a total of 16 times, which means in this bracket here, we have 16 lots of 3, which is the same thing as 16 times 3. So putting this in a calculator, 16 times 3, we know that this sum is just going to be 48. Now this next one is a bit trickier, so let's write it out and see what's going on. So first we have 5 times 1 when r equals 1, then we have 5 times 2 when r equals 2, so forth, up till 5 times 16. Well, what do we do here? It's a bit tricky to see what's going on, but what we actually have here is we can factorize out the 5, and then we have an easier sum to compute. So we'll have, putting in the square brackets, we have 5, factorizing out of everything, times 1, plus 2, plus 3, and so forth, up to plus 16. As every term has a 5 in it, we can just factorize out the 5 and left with this sum here. And now, putting this into a calculator, it's a bit tedious, but it will give us 680. Lastly, the last sum, 2 to the r. Let's write out the term and see what's going on. Well, when r equals 1, we have 2 to the 1. R equals 2, we have 2 squared. So forth up till 2 to the 16. It's a bit tricky to see what's going on here, because we can't factorize out the 2, as that will just reduce the exponent by 1, so we can't use that technique again. So what we have to realize that this is actually a geometric sequence, as we're timesing by 2 each time. Therefore, we have a geometric sequence. And now, we can use a general nth term of the geometric sequence, which is that un, I'm going to write it up here, un of the geometric sequence is going to be a, the first term of the sequence, times r, the common ratio, to the power of n minus 1. And we want to somehow equate that and put into this form. Well, the nth term of this sum here is simply going to be 2 to the power of n. But we want to make sure that these two have the same exponent, so we're going to equate the two, which means I'm going to replace this with 2 times 2 to the power of n minus 1. So all I've done there is I've factorized out the 2. And now we can see how the 2 correlate, the n minus 1 and the 2 to the 2n to the power of minus 1. So we can equate it as such. A times r to the n minus 1 equals 2 times 2 to the n minus 1. Therefore, we have a is 2 and r is 2. Now after all that, we can use a formula for the sum of a geometric series, which will be available in your formula booklet. Which will be a, the first term of the sequence, times r, the common ratio, where you multiply by each time, power of n, which is the number of terms in the sequence, minus 1, all over r minus 1. Now plugging this in, we have a, which is going to be a 2, first term of the sequence, times r, we multiply by each time 2, to the power of 16, as we have 16 terms of the sequence, all over r, which is going to be 2 again, minus 1, and that's our final sum. Putting this into a calculator, we get 131,070. Now summing all of this together, we get 131,798. Now we can compare this with the answer to the question, and we find out that we get exactly what we need, therefore we know we're right. In terms of the marking for this question, you'll get 1 mark for getting the final answer, and you'll get 1 mark for each sum you compute, for a total of 4 marks. Now that we're done with part A, let's move on to part B. So sequence u1, u2, u3 is defined by un plus 1 equals u over n, and the first term u1 is 2/3. And we need to find the exact value of the first 100 terms of this sequence. Well, the first thing we can do is let's write out the first few terms so we have an idea what's going on. So we know that u1 is going to be 2/3. We know that u2 is going to be 1 over u1, as un plus 1 is 1 over un. Which means, therefore, that u2 is going to be 1 over 2/3, which is the same as 3 over 2. Okay, well u3 is going to be 1 over u2 from the general formula they've given, which therefore means that u3 is going to be 1 over 3 over 2, which is 2/3. And now we can see that this pattern is therefore going to indefinitely repeat, which means the sum that we're looking for here, from r equals 1 to 100 of ur, is simply going to be 2/3 plus 3 over 2 plus 2/3 plus 3 over 2, and so forth, for a total of 100 times. So we want to have 100 terms there, where the final term is going to be 2/3 plus 3 over 2 at the end. And what this means is that if there are 100 terms, and half of them are 2/3, half of them are 3 over 2, then what this really means is that 50 of them are going to be 2/3, and 50 of them are going to be 3 over 2. And that's our whole sum for the first 100 terms. And all we have to do is plug this into a calculator. So we have 50 times 2/3 plus 50 times 3 over 2, which will give us 325 over 3, which is our final answer. In terms of the marking for this question, you'll get 1 mark for getting the right answer. You'll get 1 mark for realizing that this term is an indefinite sequence of 2/3 and 3 over 2. You'll get 1 mark for realizing that half of them are 2/3 and half of them are 3 over 2 for a total of 3 marks. So this question is by numerical methods. So let's read and see what's going on. The equation 2x cubed plus x squared minus 1 equals 0 has exactly one real root. Show that for this equation the Newton-Raphson formula can be written as such: xn plus 1 equals 6x squared n plus 2xn. Well, first thing we want to do is recall what the Newton-Raphson formula is, which will be in your formula book. So the Newton-Raphson formula is going to be xn plus 1 equals xn minus f of xn all over f dash xn, where the dash implies the function has been differentiated. So all we're going to do now is find the different derivative and plug it in. So if f of x is going to be 2x cubed plus x squared minus 1, then f dash x is going to be, well, we times by the power, reduce the power by 1. So 3 times 2 is 6, reduce the power by 1, 3 minus 1, 2, 6x squared. Times by the power for the x squared, 2, reduce the power by 1, 1, so x to the 1, which is just x. And minus 1 differentiated is 0. So now let's plug this in. So xn plus 1 is going to equal xn minus f of xn, which is going to be 2xn cubed plus x squared n minus 1, which is just f of x, all over the derivative, which is going to be 6x squared n plus 2xn. Next thing we want to do is, from the question, we can say we have it all as one fraction. So we want to put this together into the same fraction. And how do we do that? Well, we want to turn the xn so it has the same denominator as this bit here. So we want to times the xn by 6x squared plus 2x over 6x squared plus 2x. So we'll be left with xn times 6x squared plus 2x all over, put that as a straight line, all over 6x squared plus 2x minus 2xn cubed, this has just stayed the same, minus 1 all over 6x squared n plus 2xn. And now let's combine the fractions together. So we're going to have xn multiplied by 6x squared n plus 2xn minus, now remember, this minus is around the whole thing. So we can imagine invisible brackets around this top term here. So we're going to have minus 2x cubed n minus x squared n plus 1, as we have minus minus 1, so it's going to be plus 1. As it's minus this entire term. So when combined together, all of this becomes negative. All over 6x squared n plus 2xn. And now, expanding out the first bracket, we're going to have xn times 6x squared n, which is going to be 6x cubed n. xn times 2xn is going to be plus 2x squared n. And this is what we had before, minus 2x cubed minus x squared plus 1 all over 6x squared plus 2x. And now we can simplify the fraction, so we're going to have xn plus 1 equals this simplified. So 6x cubed minus 2x cubed, 4x cubed n. 2x squared minus x squared is going to be plus x squared. And then there are no x's and there's just a singular one. All over 6x squared n plus 2xn. And that's it for this question. And we can check with the top answer to make sure we're right. And we are exactly where we needed. So that's it for this question. In terms of the marking, you'll get 1 mark for getting the final answer. You'll get 1 mark for plugging it all in correctly into the formula at this bit here. You'll get 1 mark for differentiating the function, for a total of 3 marks. So now that we're on part A, we can move on to part B. Using the formula given in part A, with x1 equaling 1, Find the values of x2 and x3. Well, first we can recall our formula that we ended up with from part A, which was that xn plus 1 equals 4x cubed n plus x squared n plus 1 all over 6x squared n plus 2xn. This is just what our final answer was from the previous question. And now, with x1 as 1, we can find x2 and x3. So, if xn is 1, then xn plus 1 is going to be x2. So x2 is going to be 4, 1, which is x1 cubed, plus 1 squared plus 1, all over 6, 1 squared plus 2, 1. So I simply replace xn with 1 as x1 is 1, and xn plus 1 is 2 as 1 plus 1 is 2. And this, plug into your calculator, will give you 3/4. And that's x2. Similarly, we can do the same thing with x3, where x3 is going to be 4, x2, which is 3/4 cubed, plus 3/4 squared, plus 1, all over 6 3/4 squared, plus 2 times 3/4. Once again, plugging this in calculator will give you x3, which will give you an answer of 2/3. And that's it for this question. So you'll get 1 mark for finding each of them. So you get 1 mark for x2, you'll get 1 mark for finding x3. Now we're done with part B, we can move on to part C, the final part of this question. So we need to explain why, for this question, the Newton-Raphson method cannot be used with x1 equals 0. Well, first, to do this question, we need to really understand what the Newton-Raphson method is. So first I'm going to sketch out a set of axes here. So there's my y-axis, and there's my x-axis. Suppose we have some arbitrary function, f of x like this. And we're using the Newton-Raphson method to locate a root. Well, what happens is, suppose we start with this number here, xn. The Newton-Raphson method will go up to the point where the y is for the x value, and draw a tangent to that point, as such. And then, where it hits the x-axis again, that's the next value of xn plus 1. They'll go back up, hit that, and draw another tangent. And as you can see, it quickly zooms in on that root there. And that's how the Newton-Raphson method finds the root. However, suppose we chose this value here as our xn, our beginning value. Then what will happen is, it will go to where the y value is, choose that point, and draw a tangent. However, the issue is that this tangent that we have right here is completely horizontal, and so it won't actually hit the x-axis, which means that if we ever have a turning point, and we choose that as our starting value for the Newton-Raphson method, it can't be used. And we can see why here as a tangent will be horizontal, and so never hit the x-axis to find the root. Mathematically, if we write the formula for it, xn plus 1 equals xn minus f of xn over f dash xn, which is just the Newton-Raphson method formula. Well, at f dash x of n equals 0, which is a turning point, then f of xn over f dash xn is undefined, as we have something divided by 0. Consequently, that means we can never use the Newton-Raphson method at a turning point, because it would just break. And so, let's relate this to our question. So, for f of x, which in this question is 2x cubed plus x squared minus 1, f dash x is going to be 6x squared plus 2x. And that means that for x1 equals 0, we have f dash of 0, which is going to be 6 0 squared plus 2 times 0, which is 0, therefore a turning point. And so consequently, the tangent that is made will be horizontal. and thus it cannot find a root. It will be horizontal, it will not meet the x-axis, and so not locate the root. And that's it for all of this question. Now it's just the one marker, so you'll just get 1 mark for the explanation at the end. So in this question, we're told that f of x equals minus 3x cubed plus 8x squared minus 9x plus 10. And the x is a real number, which is what this means. Now we need to calculate f of 2. Well, this is pretty straightforward. So if we have f of x, we're trying to find f of 2. So we replace our x's with 2's. So we have minus 3 times 2 cubed, as that's what x is, plus 8 times 2 squared, as that's what x was, minus 9 times 2 plus 10. And plugging this into your calculator, you realize that this actually gives you 0. So that's it for the first part of A. However, let's go to the next question here. We need to now write f of x as a product of two algebraic factors, as it says in the question. So, if x equals 2 gives f of 2 equal to 0, then that means that x minus 2 is a factor by the factor theorem. So consequently, that means that we can already factorize f of x as x minus 2 times, now we don't really know what this inside bit's going to be, but let's just let it equal random letters for now. We'll get back to that in a second. So we know that this is going to be a quadratic, because we'll have ax squared plus bx plus c. We know this is going to be a quadratic in here, because if we do a cubic divided by x minus 2, then we've reduced the power by 1 everywhere, which means the cubic will now turn into quadratic. If we double check this, as if we try and find the highest x power we can make, will just be this x times by ax squared, we'll get with something cubed, so we know that this makes sense. But now the question becomes, what is a, b, and c? Well, we know that we factored f of x out, but this still equals minus 3x cubed plus 8x squared minus 9x plus 10. So now what we can do is we can compare coefficients. So, in terms of the x cubed coefficients, we know we're going to have x times ax squared there, which says x cubes will have an a x cubed on the left hand side, and on the right hand side we have a minus 3 x cubed. So therefore a is going to be minus 3. Now this is the same thing with x squareds. Now what are all the ways we make x squared on the left hand side? Well, we'll have x times bx, so we'll have a bx squared, and we also have a minus 2 times ax squared, which will give us minus 2a. And this is going to equal the x squared on this side, which is going to be 8. And therefore b is going to be 8 plus 2a. We know a is minus 3, so b is going to be 8 plus 2 times minus 3, which is 8 minus 6, which will give us 2. And lastly, let's just compare, let's skip x and we'll go straight to constants. So we'll go to, let's call the constants k. And so we're going to have minus 2 times c. That's going to be our only constants on the left hand side. And on the right hand side we have a plus 10. Now dividing both sides by minus 2, we see that c is just going to be minus 5. And now we successfully factorize this, as we just plug in these unknown constants into that, which means that f of x as two algebraic factors is going to be x minus 2 times a, which is minus 3x squared, plus bx, which is plus 2x, plus c, which is minus 5. And that's it for this part of the question. So in terms of the marking, you'll get 1 mark for finding out that f of 2 is 0. And you'll get 1 mark for finding out both of these coefficients, x squared and the x, and you'll get 1 mark for finding out the constant, for a total of 3 marks for this question. So now that we've finished with part A, let's move on to part B. Using the answer to part A, part 2, prove that there are exactly two real solutions to this equation here. Minus 3y to the 6 plus 8y to the 4 minus 9y squared plus 10 equals 0. Well, first, what did we have from part A, part 2? We said f of x, which is minus 3x cubed, plus 8x squared minus 9x plus 10, can be factorized as x minus 2 minus 3x squared, minus 3x squared plus 2x minus 5. The first thing to notice is that this equation f of x is the same equation as this equation here, except we use substitution x equals y squared. So if we take this equation here, minus 3, y to the 6 plus 8y to the 4, minus 9y squared plus 10 equals 0, and we can use the substitution that x equals y squared, then we're left with minus 3x cubed plus 8x squared minus 9x plus 10 equals 0, which is the same thing as f of x. So we can factorize it the same way. So we have x minus 2 minus 3x squared plus 2x minus 5 equals 0. Now we know one of the solutions to this, which is going to be this one here, which is that x equals 2. Now if x equals 2, we know x equals y squared, then that means that y squared equals 2, and so y equals plus or minus root 2 for this equation here. But now we also need to show that those are our two real solutions, which is what the question asks for there. However, we need to now show that this quadratic has no solutions. Now to show a quadratic has no solutions, we need to show that the discriminant, i.e. b squared take 4ac, is less than 0. As if that's the case, then the quadratic will have no real solutions. So taking this quadratic and plugging into here, b squared is going to be 2 squared, minus 4, a being minus 3, and c being minus 5. And let's see if this is less than 0. Now using a calculator, we have 2 squared, which is 4, minus, now we have minus 4 times minus 3 times minus 5, which is minus 60. And is that less than 0? 4 minus 60 is minus 56, which is less than 0. Therefore, there are no real solutions. To this quadratic. And therefore we can conclude that y equals plus or minus root 2 are the only two real solutions. And that's it for this question. Now in terms of the marking, you'll get 1 mark for deducing that there are no real solutions to this quadratic, and you'll get 1 mark for finding the two real solutions to what y is, and that's a total of 2 marks for this question. Now that part B is over, we move on to part C. Deduce the number of real solutions for this range here, theta between 7 pi and 10 pi, to this equation here, this cubic and tan theta. 3 tan cubed theta minus 8 tan squared theta plus 9 tan theta minus 10 equals 0. Well, first thing to do is look how strangely similar this is to what we had as f of x. If I write down what f of x was, it was minus 3x cubed plus 8x squared minus 9x plus 10. And now, if that is the case, then let's use the substitution x equals tan theta and see what we're left with. Now, if you use x equals tan theta in this equation here, we're left with 3x cubed minus 8x squared plus 9x minus 10 equals 0. And now, if we times both sides by minus 1 here, so we have minus 3x cubed plus 8x squared minus 9x plus 10 equals 0, we're left with what f of x is. And now we know how to factorize and solve this from earlier parts. Now from the earlier parts, we know that the only solution to this equation is x equals 2. And now we need to find out the values for theta in that range. So what we're really trying to find out is when tan theta equals 2, for that given range, how many solutions do we end up with? Well, the first thing to do is let's draw a cast diagram to help us out here. Now, how a cast diagram works is we label it as C-A-S-T, spelling out cast. Now, in this bottom right quadrant here, the C stands for cos, so this is when cos is positive. The A here stands for all, and that's when all the trigonometric values, cos, sine, and tan, are positive. The S stands here for sine, when sine is positive. And lastly, the T here stands for tan, for when tan is positive. Now, tan theta here is positive, which means we have this quadrant and this quadrant to look at. And now, let's find out what inverse tan of 2 is. So, if tan theta equals 2, then inverse tan of 2 is going to be, and we're in radians here, so be careful with your calculator, gives us 1.107, etc. So we're going to have one solution there, 0.107, etc. Another solution there, 1.107, etc. So that's going to be pi plus that solution. Now, we need to choose the number of real solutions, not actually conclude what the solutions are. Now, another thing to mention is that the number of solutions in the given range that we have here, 7 pi, theta, and 10 pi, is the same in the range of 0, theta, and 3 pi, as the amount of terms we have around are exactly the same. And the reason this works is because to get from 7 pi to 10 pi, it's a difference of 3 pi, which is 1.5 periods. And the difference between 0 and 3 pi is also 3 pi, which is still 1.5 periods. So the number of solutions in each of them will be exactly the same. So what we really need to find out is the number of solutions in this range here. So in this range here, we have 1, which is that first one there. Then we have another one here, and that takes us 2 pi round. But we need to go around at 3 pi, so that's 1.5 turns. So in that 1.5 turns, we hit this one again for the second time. So therefore, we have 3 solutions there. So our 3 solutions would be theta equals 1.107, etc. 1.107 plus pi, and 1.107 plus 2 pi. And therefore, we can conclude there are 3 solutions. And that's it for the question. In terms of the marking, you'll just get 1 mark for proving that there are 3 solutions for what theta is. And that's it for this question, it's just 1 mark. So this question involves solving trigonometric equations. So let's read and see what's going on. Solve for the range x between 0 and pi by 2. The equation 4 sine x equals sec x. First thing to do is notice that sec x is just 1 over cos x. So let's use that and see where we end up. So we're left with 4 sine x equals 1 over cos x. So let's times both sides by cos x to simplify the equation. By the way, I've just replaced sec x with 1 over cos x here. So now we're left with 4 sine x times cos x equals 1. And now, we might be a bit stuck here, but what we need to realize is that we can use our double angle formula here, because we have a sine times a cos. And the double angle formula for sine is 2 sine x cos x equals sine 2x. You can get this from your formula book. So to make this left-hand side match that, let's divide this by 2. So now we're left with 2 sine x cos x equals a half. And now place it with sine 2x, we're left with sine 2x equals a half. Now before we start solving this question, bear in mind that we now have 2x instead of just x, which means our original range has gone from 0 to pi by 2 to 2x is between 0 and pi. Now we know that, we continue solving our question. So 2x is therefore going to be inverse sine of a half. Now, we can use a cast diagram to help us here. C-A-S-T, written like that. What the cast diagram tells us is when trigonometric curves, so sine, cos, and tan, when they're positive and when they're negative. So C here in this quadrant here is when cos is positive, but sine and tan are negative. A here stands for all, when all of them are positive. S here stands for sine, when just sine is positive, but not tan or cos. And T here is when tan is positive, but not cos or sine. Now we're dealing in the two areas, the two quadrants rather, where sine is positive, because we have a half, not negative half, which means we have this quadrant here and this quadrant here. So we can draw lines like that, and we can fill in our angle like that. So first let's do inverse sine of a half, and make sure we're in radians for this. And we're left with pi over 6, which is that this angle here is pi over 6, and this angle here is pi over 6. Which means our two solutions is that 2x equals pi over 6, which is this one here, but also pi minus pi over 6, as we're going a whole time round and back pi over 6. So that's going to leave us with 5 pi over 6. And now we want to find out what x is, not 2x, so dividing both sides by half, we have x equals, one more thing, is we've only gone round once pi amount of times, because we're in the range 0 to pi, and not anymore. So we only have two solutions now. Now, dividing both sides by 2, we have x is pi over 12 and 5 pi over 12. And that fits in the range of our original range between 0 and pi over 2. So that's it for this question. In terms of the marking for this question, you'll get 2 marks for finding 2 solutions, a mark for using the double angle formula, and a mark for realizing that sec x is 1 over cos x. And that's it, 4 marks for this question. So let's move to part 2 of this question. Solve for the range of theta between 0 and 360 degrees, the equation 5 sine theta minus 5 cos theta equals 2. We need to give answers to one decimal place. First thing to notice is that we're in the range of 0 to 360, so let's change our calculated degrees so we're not in radians anymore. Now, to solve this equation here, we're going to have to express, we can't solve it normally, so what we need to do is express 5 sine theta minus 5 cos theta into one trigonometric form. And to help us here, we can use the compound angle formula. So compound angle formula, say we have sine theta minus alpha. Well, that's the same thing as sine theta cos alpha minus sine alpha cos theta. And now let's times everything by, let's say, r. Then we're left with r sine theta minus alpha equals r sine theta cos alpha minus r sine alpha cos theta. Now we want to express this into one trigonometric form, which is this. So what we're going to do is we're going to equate this right hand part of the equation here to this, and then we can solve for r and alpha, and then plug r and alpha into here, so we have this expressed as one trigonometric form. So let's do that. So now we have r sine theta cos alpha minus r sine alpha cos theta, which equals 5 sine theta minus 5 cos theta. And now what we're going to do is we're going to compare coefficients. So the first thing to do here is let's compare coefficients of sine theta on both sides. So comparing coefficients of sine theta, we have on this side, our coefficient of sine theta is going to be r cos alpha. So we're going to have r cos alpha on this side. And our coefficient of sine theta on this side is just going to be 5. So we have that. And I'm going to call this equation number 1. Now let's compare coefficients of cos theta. Well, coefficient of cos theta on this side is going to be minus r sine alpha. So on this side we have minus r sine alpha. And on the opposite sides we have minus 5, the coefficient of cos theta. And I would actually simplify this expression by just cancelling out the negatives on both sides. So we just have r sine alpha equals 5. I'll call this equation 2. Now in order to solve for what alpha and r are, we can use some trig identities. So first thing we can do is let's take 2, equation number 2, and divide it by equation number 1 and see what we're left with. So doing this, equation number 2, r sine alpha, divided by equation number 1, which is r cos alpha, is going to give us 5 over 5. And simplifying this, well, the r's cancel out here, and sine alpha over cos alpha is just tan alpha. And 5 over 5, well, that's just 1. And now we simply just take the inverse of 1 and find out what alpha is. So alpha is going to be inverse tan of 1, which using a calculator will give you 45 degrees. And now let's find out what r is. So now what I'm going to do is I'm going to do the equation 2 squared plus equation 1 squared and see what we're left with now. Now equation 2 squared will give us r squared sine squared alpha plus r squared cos squared alpha, which equals 5 squared plus 5 squared. And now what I can do is I can factorize out the r squared here. So I'm left with sine squared alpha plus cos squared alpha, which equals 5 squared plus 5 squared, which is 25 plus 25, which is just 50. And now what I can do is I can use a trigonometric identity that sine squared alpha plus cos squared alpha equals 1. And so I can cross this out and this just equals 1. So now what I'm left with is r squared equals 50. And so r is the square root of 50, which simplified into 1/3 will give me 5 root 2. So now what I can say is that the expression we had before can be simplified as just 5 root 2 sine theta minus 45, 5 root 2 is r, and alpha was a 45, equals 2. Now this becomes a much easier question to solve. So first I'll divide by 5 root 2, so I'm left with sine theta minus 45. Now 2 divided by 5 root 2 and simplified will give you root 2 over 5. Now I can take inverse sine of both sides, so I have theta minus 45 equals inverse sine of root 2 over 5, which gives me 16.4299 ... However, this isn't all, as we have one more solution to look for as well. Remember that our given range was from 0 to 360. So we need to find all the sine values in that range. So using our cast diagram here, which I can draw neatly in here, where this is C, A, S, T cast, where this region for C represents when cos is positive, this region represents by A is when all trig equations are positive, this region represented by S is when sine is positive, and this region here with T is when tan is positive. And so sine is a positive function here, which means we're looking at these two quadrants. So we have one solution for sine, which is this angle here, 16.429 and so on. But we also have this other solution for sine here, where that angle is 16.429. However, the full way round is going to be 180 minus that solution. So 180 minus 16.4299, etc. will give me 163.57, etc. And we don't have any more solutions, because if you go around this 360 degrees, well, we only get 2 solutions. And now this is the answers for theta minus 45. But we're looking for the answers of just theta. So let's add 45 to both of these solutions. So 16.4299, etc., plus 45, which gives us 61.4, and 163.57 plus 45 gives us 208.6. And both of these, if you've noticed, are to 1 decimal place, as that is what the question asked for. We need it to 1 decimal place. And that's it for this question. In terms of the marking, you'll get 1 mark for getting both of these right answers. You'll get 1 mark for getting to this stage before you add on the 45, so that's 2 marks. You'll get 1 mark for finding what r is. You'll get 1 mark for finding out what alpha is. And you'll get 1 mark for even trying to apply the r sine theta minus alpha equation, for a total of 5 marks for this question. Okay, so in this question, we're told that figure 1, this graph here, is a graph showing the trajectory of a rugby ball. The height of the ball above the ground h meters, which is the y-axis here, has been plotted against a horizontal distance x meters, the x-axis here, measured from where the ball was kicked, which is the origin here. And the ball travels in a vertical plane, which tells us that this is just a 2-dimensional problem. Now it goes on to say that the ball reaches a maximum height of 12 meters and hits the ground at a point 40 meters from where it was kicked. And we need to find a quadratic equation linking h with x in both situation. Well, first let's use this information here to plot the points of the graph. Well, we know the maximum height is 12, which is at this point here. That's the turning point of the quadratic, so that's 12. We know that this is 40, as that's where it lands. Now, because we also know that quadratics are symmetrical, we know this point here, where its maximum height must be 20. So now that we know all of that, we can go on to find a quadratic. Now we know the quadratic is going to be in the form of h equals ax squared plus bx plus c. And then we just need to find out what a, b, and c are. Well, we know 3 points along this quadratic. There's 0, 0, where it starts. It's 20, 12, the maximum height of the ball. And there's also 40, 0, where the ball ends up. So first, let's plug in 0, 0 into this quadratic and see what we end up with. Well, h is 0. Then we'll have a, 0 squared, plus b times 0 for x's, plus c. Well, we know that a and b both cancel out, because that's both 0. So left with c equals 0. Okay, now let's use the next point here, 20, 12, and see what we get. So, when h is 12, x is 20, which is going to be a times 20 squared, plus b times 20. And we have to write plus c because we know plus c is 0. Now simplifying this, we get 12 equals 20 squared, which is 400, 400a, plus 20b. Well, we can't directly solve this as we have two unknowns in one equation. So let's use our final point here and plug into here and see what we end up with. So, h is 0 here, x is 40, so we have a times 40 squared, we have b times 40, and then we know it's plus c because it's 0. Simplifying this, we have 40 squared, 1,600, a plus 40b. And now we can solve for a using this equation, plug into here, and then solve for b as well. And then plug it back into a and find out what a is. So, 1,600a equals minus 40b, just taking away 40b here. Then divide by 1,600 leaves us with minus 1 over 40b. Now I can plug that into this first equation here. It's left with 12 equals 400 times minus 1 over 40b plus 20b. Simplifying, we have 12 equals 400 times minus 1 over 40, which gives us minus 10b plus 20b. So 12 equals 10b. And finally, that means that we know that b equals 1.2. From here, we can find out that a equals minus 1 over 40 times 1.2, which leaves us with minus 0.03. So finally, our answer will be h equals a minus 0.03x squared plus b 1.2x. However, we can still simplify this further by factorizing out the x. So really we can write this as x times minus 0.03x plus 1.2. That right there is a final answer. In terms of the marking for this question, we get 1 mark finding the final answer, we get 1 mark finding out what b is, and we get 1 mark finding what a is. And that right there is a total of 3 marks. Now that we're done part A, we can move on to part B. So in part B, it tells us the ball passes over a horizontal bar of a set of rugby posts that's perpendicular to the path of the ball. And the bar is 3 meters above the ground. Use your equation to find out the greatest horizontal distance of the bar from O. So what this question is basically telling us, sort of in disguise, is greatest horizontal distance from the bar from O is just known as x, and bar is 3 meters above the ground is just RH. So what this question is really saying is we need to find out what x is when h is 3. Now going back to a quadratic, we have h, which equals minus 0.03 x squared plus 1.2x. And we need to find out what x is when h is 3. So when h is 3, we get minus 0.03x squared plus 1.2x. Now I'm going to add 0.03x squared and take away 1.2x, get everything on the same side. So now we're left with 0.03x squared minus 1.2x plus 3 equals 0. And now we're left with a quadratic that we can try and solve. So first thing I'm going to do is simplify the quadratic. So 0.03 as a fraction can be written as 3 over 100. So what I'm going to do is I'm going to times everything here by 100 and then divide it by 3 to get the x coefficient as 0. So x squared minus, now 1.2 times 100 divided by 3 gives me 40, so I have minus 40x. Now 3 times 100 divided by 3 will give me 100. That equals plus 100 equals 0. Now I've just done this to simplify the quadratic. Now what I can do next is complete the square on this quadratic. So x minus 20 squared, and what I've done here is half the 40, and then so I've got minus 20 in there, minus 20 squared plus 100 equals 0. Bringing the 20 squared and the 100 to the other side gives me the x minus 20 squared equals 20 squared minus 100 on the right hand side, which leaves me with 300. Taking the square root of x minus 20 equals plus or minus square root of 300. Finally, I'm left with x equals 20 plus or minus square root of 300. But which solution do I choose here? Well, it says in the question that we need to find out the greatest horizontal distance from the bar from O. And 20 plus 300 is greater than 20 minus 300. Therefore, we know that our solution is going to be x equals 20 plus the square root of 300. And in meters, this will give us, using a calculator, like 20 plus square root of 300 will give us 37.3 meters to 1 decimal place. And that's it for this question. In terms of the marking, you'll get 1 mark for getting the correct answer. You'll get 1 mark for finding the solution, 2 solutions for x's, and you'll get 1 mark for forming the quadratic here, for a total of 3 marks for this question. For the last part of the question, we need just to give one limitation of the model. And the simplest one to give is that there is no modeling of air resistance on the ball. In reality, air resistance will act on the ball, decreasing the distance that will travel both vertically and horizontally. Now answer will give you the 1 mark you need for the question. So this question is about differentiating from first principles. Let's read and see what's going on. Given that theta is measured in radians, prove from first principles, so differentiating first principles, the derivative of cos theta is minus sine theta. And we're allowed to use the cos compound angle formula, as well as these 2 limits which may come into use later. Well, first, what does it mean to differentiate from first principles? Essentially, suppose we have some function f of x equals y. Well, by differentiating, we find the gradient of the function. Another way to find the gradient of the function is typically we find this y2 minus y1 over x2 minus x1. So the difference in y, or the change in y, over the change in x. Now, for the derivative, say f dash x, the formalism we use is that we think about the limit as h approaches 0 of f of x plus h minus f of x over h. So you can think of f of x as original y point and f of x plus h as our second y point. So we have y2 minus y1 at the top. And at the bottom, we have x2 minus x1. Now x1 is x and x2 is x plus h. Then x plus h minus x just leaves us with h. So we have an h on the bottom. So this right here, we're finding the gradient of the function. So we're differentiating here to find the gradient of the function. And we want to find the limit as this approaches 0, as that'll give us the exact derivative. And you can find this formula in your formula booklet. So now we know what we're doing. Let's differentiate cos theta and see what we get. So let's call this f of theta. Well, in that case, f dash theta, if f of theta, well, f of theta equals cos theta. And if that's the case, then f dash theta is going to be the limit as h approaches 0 of cos theta plus h minus cos theta all over h. Now, we want to expand out this cos theta plus h, and we can do so by the hint of the question, which is we're allowed to use a compound angle formula. So, cos theta plus h is the same thing as cos theta cos h minus sine theta sine h. And this is just the compound angle formula for cos. So continuing on with this, we have the limit as h approaches 0 of cos theta cos h minus sine theta sine h minus cos theta. This is all going to be over h. And now, what I'm going to do here is I'm going to group up the coses and the sines here and see what we're left with. So we're trying to find the limit as h approaches 0 of cos theta cos h minus cos theta all over h plus the sine part, which will be the limit as h approaches 0 of minus sine theta sine h all over h. Now what we can do next is, taking a look here, the limit only depends on h, as we're trying to limit as h approaches 0, which is what we can do is we can take out the cos theta from this part of the expression and take the sine theta from this part of the expression. So we just have h's in there. So doing that, taking out the cos theta, factorizing it out, we have cos theta times, I'll put this in square brackets, the limit, so h approaches 0 of, now cos theta cos h divided by cos theta is going to be cos h, and minus cos theta divided by cos theta is going to give us 1, so we have cos h minus 1 all over h. And the second part here, I'm going to take out minus sine theta here, so I'll have minus sine theta multiplied by the limit as h approaches 0 sine h over h. Now at this stage here, we can use the hints we're given in the question. So in the question, we're told that as h approaches 0, sine h over h approaches 1. Here we have h approaches 0, so sine h over h, well, that's going to approach 1. So this whole part just becomes 1. And then using the second part here, as h approaches 0, cos h minus 1 over h approaches 0. And that's what we have here. The limit as h approaches 0, cos h minus 1 over h approaches 0. Which means this part here is going to be 0. But in that case, we have cos theta times by 0, which means this part also goes to 0. So all we're left with now is just minus sine theta from here. And that's exactly what we need for the question. The derivative of cos theta is minus sine theta. So that's it for this question. Lastly, for the marking, for using the first principles derivative formula on the function, you'll get 1 mark. For using the compound angle formula successfully, you'll get 1 mark. For factorizing out the cos theta and sine theta, you'll also get 1 mark, as I've done there. That's 3. You'll get 1 mark for cancelling out the expressions and using the limits, so one is 0 and the other one is 1. So that's 4. And lastly, you get 1 mark for getting the right answer, for a total of 5 marks.
We are told a spherical mint of radius 5 mm is placed in the mouth and sucked. 4 minutes later, the radius of the mint is 3 mm. In a simple model, the rate of decrease of the radius of the mint is inversely proportional to the square of the radius. We're told, using this model and all the information given, Part has asked us to find an equation linking the radius of the mint and the time. We're told you should define the variables that you use, and this part is worth 5 marks. The first thing I'm going to do is I'm going to define the variables I'm going to use in this question, okay? Because before we can begin interpreting what we've been told, we need to know how to write it in, okay? So what I'm going to start by saying is I'm going to start by saying R equals radius of mint, okay? And the units we're going to do this in is millimeters, because that's what we've been given it in, okay? Then, what I'm going to do is I'm going to say that time, or t, equals just the time, okay? Time elapsed, okay? And we have a choice here. We can do it in minutes or seconds. The mark scheme has given credit for both. So what I'm going to do is I'm just going to stick to minutes, because that's what we've been given it in terms of. So I'm just going to say minutes, like this, okay? Now we know our units, we can start interpreting our question. So when it says a spherical mint of radius 5 mm is placed in the mouth and sucked, what this means is, it means that at a time of 0, okay, the radius of the mint is 5 mm, okay? So that's good. 4 minutes later, the radius of the mint is 3 millimeters. Okay, so what we can highlight is 4 minutes later, the radius of the mint is 3 millimeters. Okay, and what this means is, at a time of t equals 4, the radius equals 3. Okay, so 3 millimeters, but because we've already specified down here that it's in millimeters, that's all good. In a simple model, the rate of decrease of the radius of the mint is inversely proportional to the square of the radius. Okay, so the two key points we need to highlight here are the rate of decrease of the radius, so rate of decrease of the radius, and that is inversely proportional to the square of the radius. Okay, the reason these are important is because now what we can say is, well, the rate of decrease of a radius just means that it is minus dr by dt, because this is the rate of change of the radius with respect to time. Okay, and then inversely proportional, so this is going to be proportional to 1 over r squared. Okay, so what we can do is we can say, since minus dr by dt equals, is proportional to 1 over r squared, this means that dr by dt equals minus k over r squared. Okay, so what we've done is we've taken the fact that it's a rate of decrease, so it's negative dr by dt, and we've taken that inversely proportional, and we've used the definition that when something's inversely proportional, it equals minus k over something, and it's the square of the radius, so it's minus k over r squared. Okay? The next step is to try and solve it. So what I'm going to do is I'm going to rearrange this to bring all the terms of r onto one side, and then minus k and dt on the other side. Okay? So you multiply both sides by r, so we will end up with r squared dr by dt equals minus k. Multiply both sides by dt, so we have r squared dr equals minus k dt. Okay? The next thing I'm going to do is I'm going to use the rule that if we have a dx, which equals b dy, say, then the integral of a dx equals the integral of b dy. Okay, so what we're going to say is that this becomes the integral of r squared with respect to r equals minus k, because in this case k is a constant, so we can take it outside the integral, times dt. Okay, carrying out the integration, we get r cubed over 3 equals minus k, and then dt, the integral of just dt is t. And then because we've integrated and it's indefinite, we need our constant of integration. So that's going to be plus c, like this. Okay? Now, we have our model in terms of k and c, but what we need to do to find the full model is we need to find what k and c are. Okay? And the way we're going to do this is actually we're going to use the values we've been given. Okay? So we've been told that t equals 0 and r equals 5. So at t equals 0, r equals 5, and t equals 4, r equals 3. Okay, so I'm just going to write these down here just to keep them. Okay, so I'm going to say t equals 0, r equals 5, and t equals 4, r equals 3. Okay, so what we're going to do to find this constant c here is we're going to use the initial conditions, which is where t is 0 and r equals 5. That's a trick. If you ever need to find the constant of integration, just look at the initial condition. Okay, so what we're going to say is r equals 5, so we're going to have 125 over 3, because 5 cubed is 123. Okay, just let me draw actually what I'm doing. So we're going to plug in t and 0, and we're going to plug in 5 for r. Okay, so we have 125 over 3 equals minus k times 0 plus c. So minus k times 0 becomes 0. Okay, so we're left with that c equals 125 over 3. Okay, now what we need to do is we need to find k. So I'm just going to rewrite our equation and say r cubed over 3 equals minus kt times plus 125 over 3, like that, okay? So what we're going to do is we're now going to put in that t equals 4 and r equals 3. So what we're going to say is 3 cubed over 3, so that's 27 over 3, so that's 9, equals minus 4k, so t equals 4, plus 125 over 3, okay? What we get here is that 4k equals 125 over 3 minus 9. So all I've done is move 4k to the other side and bring 9 to this side. So we've got 4k and minus 9. And then solving this, you will get that k equals minus 49 over 6. Like that, okay? So what you can do, you just put this into the calculator, divide it by 4, and you get k, okay? So in conclusion, we can say, therefore, the equation for our model is, and then it's going to be r cubed over 3, okay, equals minus 49 over 6 plus 125 over 3. So this question is worth 5 marks. Your first mark comes from translating the word problem we've been given and getting that either dr by dt is proportional to 1 over r squared, or that dr by dt equals k over r squared. Now if you've got plus or minus, it doesn't matter, so we get this mark here, okay? The next step is to integrate our differential. So knowing you need to rearrange to get r squared dr equals minus k dt, so our line here, and knowing you need to integrate that, so this line here gets us our second mark. Our third mark comes from getting the correct result of the integral. Now our fourth and fifth mark, you get your fourth mark for correctly using the values you've been given to get the equation, okay? And your fifth mark comes from defining your variables correctly. So saying that r is a radius and t is a time in minutes, okay? Now, technically, you could have defined other variables, but if they told us radius, r, and time, t, they make the most sense. So always choose the variables which make the most sense in terms of the question. So this will get us our fifth and final mark. Part B has told us, hence, find the total time taken for the mint to completely dissolve. Give your answer in minutes and seconds to the nearest second. Okay? So this question is actually relatively straightforward. When the mint has completely dissolved, okay, what this means is the radius of the mint is 0 millimeters. Okay? I'm also going to highlight that we need to give our answer in minutes and seconds and give it to the nearest second. Okay? So, what we can do is we can say at r equals 0, we will have 0 cubed over 3 equals minus 49 over 6t plus 125 over 3. 0 cubed over 3, so this will be eliminated entirely and this will just become 0. So what we will end up with is 49 over 6t equals 125 over 3. Multiplying both sides by 6, you will end up with 49t equals, so this will be 6 over 3, which is 2 times 125, which is 250. And this means that t equals 250 over 49, which equals 5.102, etc. Now we need to be very careful here with our units. So our units are minutes, because the equation we're using here was defined in part A in terms of millimeters and minutes. Okay, so we have 5.102 minutes. Okay, to convert this from minutes to minutes and seconds, all you do is you say that this is therefore 5 minutes. Okay, and then you do 0.102 times 60 to get the number of seconds, and this is 5 minutes 6 seconds. Okay, putting this into your calculator, you will get 6.1224 etc. seconds, but that rounds down to just 6 seconds. And because the question asked us to give it to the nearest second, we do like this. Okay. So this question was worth 2 marks. Your first mark comes from knowing that r equals 0, and then correctly rearranging your equation to get it in terms of t equals something. So up until here, we have our first mark. Your second mark comes from correctly converting your time into 5 minutes and 6 seconds. Part C has asked us to suggest a limitation of the model for 1 mark. So you could have quite a few answers for this question as long as they make sense or valid. The one I'm going to go with is that the mint may not retain the shape of a sphere. Okay, so mint may not retain the shape of a sphere. Okay, and what this means is it will not have a uniform radius. Okay, so just in brackets, not have a uniform radius. Okay, and the reason this is problematic for the model, or it's a limitation, because the model was devised by assuming that the mint is spherical, or that it maintains a spherical shape throughout the time period. Okay, so if at any point it loses its spherical shape or becomes more like an oval or something like that, then the model is not actually applicable to that new shape, and there needs to be a new model for it. Okay, so that would mean that that is a limitation of the model. Okay, so this question is 1 mark, and this will get us our 1 mark just fine. If we come down to the bottom of the page though, what I have included are some alternative answers. Okay, so I'll just read them now. So model does not consider how the mint is sucked, so whether it's done evenly or not. So that's sort of in the end going to result in maybe not retaining the spherical shape. The model does not consider whether the mint is bitten. Okay, so if you bite it. The model is limited for times up to 5 minutes 6 seconds. Okay, so if you notice, our model, it didn't have sort of any endpoint for the time period. Okay, so that's something we need to say, because if we leave it for like a longer time, so say a time of 6 minutes, then it's probably going to indicate a negative radius, which is impossible. Okay. Not valid for times, but yeah, that's the same thing. Mint may not retain the shape of a sphere, which is what we said. The model indicates that the radius of the mint is negative after it dissolves, so that is the same thing as the model is limited for times up to 5 minutes 6 seconds. Okay, model does not consider the temperature in the mouth. So typically models, they are used to simplify real world things. Okay, the problem is that there is more than one factor apart from time which affects how quickly the mint dissolves. Okay, so again, temperature is one of those, and as well the rate of saliva production. Saliva is what's going to help digest or break down the mint. Okay, mint could be swallowed before it dissolves in the mouth. That is another possibility for what could happen.
We are being given a fraction, which is 1 plus 11x minus 6x squared, all over, and then in brackets, x minus 3 times 1 minus 2x. And we're told it's identical, as denoted by this identity sign here, to a plus b over x minus 3a plus c over 1 minus 2x. We have been asked in part A to find the values of the constants a, b, and c for 4 marks. Okay, I'm going to highlight that a, b, and c are constants. Okay, and the way I'm going to go about solving this question is I'm going to try and manipulate the right hand side so the two denominators match. Okay, so just as a recap, if you have, say, 3 fractions, so you have a over b plus c over d plus e over f. Okay, what you need to do is you need to do ADF plus CBF plus EBF, and then you can divide it, or you do all over BDF, okay? Because then they'll have a common denominator of BDF, and you can add them. So that's sort of what we're going to try and accomplish with our partial fraction form here, okay? So what I'm going to do is I'm going to start by writing 1 plus 11x minus 6x squared over x minus 3 times 1 minus 2x equals, is identical to. Okay, so the first thing to get x minus 3, 1 minus 2x for a is we need to multiply the numerator and denominator both by x minus 3 times 1 minus 2x, okay? So we end up with a x minus 3, 1 minus 2x. to get b in the correct form, it's already got an x minus 3 in the denominator, so all we need to do is multiply it by 1 minus 2x, so b 1 minus 2x, and then same thing with c, it's already got 1 minus 2x, so all we need to do is multiply by x minus 3, okay? All of this will then be divided by x minus 3, 1 minus 2x. Now, at this point, we're going to use another rule, which says if you have a over is identical or is equal to c over b, what this means is a equals c, okay? So what we're going to say is 1 plus 11x minus 6x squared equals a x minus 3, 1 minus 2x, plus b 1 minus 2x, plus c x minus 3. Okay? So, now to find each of our constants, what we need to do is we need to eliminate the other terms. Okay? So say I want to find what the value of b is, I need to eliminate a and c. And the way we're going to do that is we're going to be looking at the x terms in each of them. Okay? So, to find a is going to be a bit harder because we've got both x minus 3 and 1 minus 2x. So we'll come back and we'll do that at the end. But to do b is going to be relatively straightforward. So we can say to find b, okay, we need a and c, the x terms making up a and c to be 0, okay? So we can say x minus 3 equals 0 because x minus 3 is the only one which appears in both of them, okay? This means that x equals 3, alright? Now I'm going to plug in x equals 3 into this side and into this side, okay? And I'm going to solve it. So it's going to be 1 plus 11 times 3 minus 6 times 3 squared equals, so a times 3 minus 3 is going to be a times 0 times 1 minus 2 times 3, so that's just going to be 0, okay, plus b, 1 minus 2 times 3 is 6, so it's going to be 1 minus 6, 1 minus 6 is minus 5, and then c is going to be c times 3 minus 3, and 3 minus 3 is 0, so it's just going to be 0, so we can leave that. Okay, if you were to put this into your calculator, you would end up with 1 plus 33 minus 54, okay, which is minus 20. So we have minus 20 equals minus 5b, and what this means is b equals 4. The next step is to find c, and we're going to just use the same principle here. So say to find c. Now we need the term which makes b and a 0, and that's 1 minus 2x. So we're going to say 1 minus 2x equals 0. So we get 2x equals 1, and therefore x equals 0.5. Again, I'm going to plug x equals 0.5 into our left hand and our right hand side, and we're going to solve for c. So we're going to have 1 plus 11 times 0.5 minus 6 times 0.5 squared equals, so a is going to be a times x minus 3 times 0, so it's just going to be 0, plus b, so b times 0, so that's going to be 0, and then c, so 0.5, minus 3 is minus 2.5, so it's minus 2.5 c, okay? Now, 1 plus 11 times 0.5 minus 6 times 0.5 squared, if you put that into your calculator, will get you 5, okay? So this will be 5 equals minus 2.5c, and this means c equals minus 2. Alright? Now before we find a, I'm just going to take a step back. I'm just going to rewrite what we know so far. So we know that 1 plus 11x minus 6x squared equals a x minus 3, 1 minus 2x, plus b, now we said b is 4, so it's going to be plus 4 times 1 minus 2x, and then plus c, but c is minus 2, so it's going to be minus x minus 3. Okay? Now to find a, we can't really substitute anything to make the rest of the terms 0, because anything we plug in will also make a times 0, so it will remove it. So what I'm going to do is I'm just going to let x equal 0, and we're going to solve for a in that way. Okay, so we're just going to say x equals 0. This means we have 1 plus 11 times 0 minus 6 times 0 equals a, so 0 minus 3, and then so that's minus 3. 1 minus 2 times 0, so that's going to be 1. So it's going to be a times minus 3 times 1, so it's going to be minus 3a. 1 minus 2x, so it's going to be 1 minus 0, which is going to be 1, which is going to be plus 4. And then minus 2 times minus 3 is 6. Okay, so we end up with 1 equals minus 3a plus 10, minus 3a equals minus 9, and a equals 3. Okay, final step is just to write it all nicely to the examiner. Okay, so what I'm going to say is 1 plus 11x minus 6x squared over x minus 3 and 1 minus 2x is identical to 3 plus 4, so b over x minus 3, and then plus c, but c is minus 2, so it's going to be minus 2 over 1 minus 2x. Okay, this isn't necessarily required because we've only been asked to find a, b, and c, but you know, it's nice to write it in the final form that was given to us in the question. So this question is worth 4 marks. Your first mark comes from knowing you need to manipulate the right-hand side to get it into this form here. Okay, so to get 1 plus 11x minus 6x squared equals a x minus 3 times 1 minus 2x plus b times 1 minus 2x plus c x minus 3. Okay, your second mark comes from getting that a equals 3, okay, so you could have done this a magnitude of ways, but if you've shown somewhere that a equals 3, you get your second mark. If you've shown somewhere that there is an attempt to find either b or c, and you get b equals 4 or c equals minus 2, you get your third mark. Now we've gotten b equals 4, so we can secure our third mark, and then your final mark comes from as well solving c and getting the correct final answer as we have here. We have been told fx equals 1 plus 11x minus 6x squared over x minus 3, 1 minus 2x, where x is greater than 3. We have been told to prove that fx is a decreasing function for 3 marks. Okay, so I'm first going to highlight the keyword, which is prove, and I'm going to highlight that we need to show that fx is a decreasing function. Okay, and the reason this is important is because a decreasing function, effectively what it means is, it means we need to show that the first derivative is less than 0 for all x in our domain. Okay, so the first step is actually to differentiate fx. But before we do that, what I'm going to do is I'm going to rewrite fx in a nicer form to work with. So I'm going to say fx equals 3 plus 4 times x minus 3 to the power of minus 1 minus 2 times 1 minus 2x to the power of minus 1. Okay? Now, what we can say is the derivative of fx equals derivative of 3 with respect to x is 0. Now, 4 times x minus 3 to the power of minus 1. If you were to take a u substitution, say u equals x minus 3, du by dx equals 1, so that doesn't change. The minus 1 comes down as a power, so it's going to be minus 4, okay, because we've got the 1 from the du by dx, so that doesn't change. X minus 3 to the minus 2. Now, minus, so this one's going to be a bit more tricky, because if you do u equals 1 minus 2x, what you will end up with is du by dx equals minus 2. So you will end up with this minus 2 times the minus 2, which comes from your du by dx, to get 4. So it would be 4 times 1 minus 2x to the minus 1. The minus 1 comes down to make it minus 4. And then it's 1 minus 2x to the minus 2. Okay? Minus 4 times 1 to the minus 2x to the power of minus 2. Okay? So we're going to just rewrite it in a much nicer form. So what I'm going to say is, first actually, we're going to use the rule that a to the minus n equals 1 over a to the n. And I'm going to rewrite all of these in terms of fraction form. Okay, so we're going to say this is minus 4 over x minus 3 squared. Okay, now what I'm going to do here is I'm going to write plus and then minus 4 over 1 minus 2x to the minus 2. Okay, not to the minus 2, sorry, just to the power of 2. And you're going to see in a second why I'm doing this. Okay, now we know that we are only considering this from when x is greater than 3. Okay, so what we need to say is x minus 3 squared. So when x is greater than 3, okay, say 3, when you put in 3, you have 3 minus 3, which is 0, so 0 squared is 0, okay? But whenever it's greater than that, whatever the difference is, because we're squaring it, it's always going to be greater than 0, okay? So what we need to say is, this is greater than 0 for all x is greater than 3, okay? The same thing applies for 1 minus 2x all squared, okay? Because whatever value you put in, regardless of the result of 1 minus 2x, it will be squared, so it will always be positive, okay? So this is going to be positive for all x is greater than 3, okay? Now, if we look here, what this means is 4 over x minus 3 squared, so ignore the minus for now, the 4 over x minus 3 squared will be positive, but this negative will make it negative, okay? So what we can say is that therefore minus 4 over x minus 3 squared is less than 0, and minus 4 over 1 minus 2x all squared is less than 0. Because in both cases, we're taking 4, which is a positive number, we're dividing it by a positive number, which means it's positive, and we're multiplying it by minus 1, which makes it negative. Okay? So what we need to say then is, we have shown that minus 4 over x minus 3 squared and minus 4 over 1 minus 2x squared is less than 0 for all x is greater than 3. So that's the first point we need to make explicitly clear to the examiner. Okay, so that we have shown that the fractional components are negative. Okay, what we need to say then is, and this is why I wrote addition in when I converted them back into fractions, okay, we're then going to say that the derivative of fx is the sum of two negative numbers. Okay, probably numbers isn't the right word actually. Two negative fractions. Okay, because these can be algebraic and so on. Okay, so it's the sum of two negative fractions. Okay, so what this is saying is that we take one negative and we add it to another negative. Okay, and because of BIDMAS, the result will always be even more negative. You can't take one negative, add a negative, and get a positive. Okay, it's always negative plus a negative is even more negative. Okay, so we need to say now, therefore, fx is less than 0, okay, because it is the sum of two negative functions, okay, and then from here we conclude and say this implies that fx is decreasing, because remember we said the characteristic of a decreasing function is that the derivative of the function is less than 0 for all x values. Okay, so that would conclude this question. So, for this question, you get 3 marks, okay? You get 2 marks for correctly differentiating your fx, okay? So, up until here, gets us our first 2 marks. Your third mark, what you need to do is you need to explicitly show the examiner how you're getting to it becoming a decreasing function. So that means explicitly stating that x minus 3 squared and 1 minus 2x squared are both greater than 0, okay? And since the derivative of fx is the sum of two negative fractions, it means the derivative of fx is also always going to be less than 0, and using that to imply that fx is decreasing. So using the definition of a decreasing function and in relation to its derivative. So that gets us our third and final mark for this question. We have been asked to prove that 1 minus cosine 2 theta is identical to tan theta sine 2 theta, where theta isn't an odd multiple of pi over 2 and where n is an integer, okay? And this question is worth 3 marks. So you have two ways to do this. The first way is you can go from 1 minus cosine 2 theta to tan theta sine 2 theta, so that's the first way. Or the other way is you can go from tan theta sine 2 theta to 1 minus cosine 2 theta, okay? I'm going to choose the latter, so I'm going to go from tan theta to sine 2 theta, just because I think it's easier, okay? And the marks can credits both ways, so don't worry about it. The first thing I'm going to do is I'm going to use the identity that tan theta is identical to sine theta over cosine theta, okay? So what this means is that tan theta sine 2 theta equals sine theta over cosine theta times sine 2 theta, okay? The next thing I'm going to do is I'm going to use the identity that sine 2 theta, okay, is identical to 2 sine theta cosine theta. And what this means is we will get that we have sine theta over cosine theta times 2 times sine theta times cosine theta, okay? From here, the two cosine thetas cancel, so what we are left with is that this equals, okay, 2 sine squared theta, alright? Now, what we need to do is we need to use another trigonometric identity, okay? And that identity tells us that cosine of 2 theta equals 1 minus 2 sine squared theta, okay? What we're going to do is we're going to rearrange this for 2 sine squared theta. So this means that 2 sine squared theta equals 1 minus cosine of 2 theta. And by extent, we get that this here equals 1 minus cosine 2 theta as required. So this question is worth 3 marks. Your first mark comes from using that tan theta is identical to sine theta over cosine theta, and that sine 2 theta is identical to 2 sine theta cosine theta, to get this line here, so up until this, okay? Your second and third mark come from doing the simplification of cosine theta to get 2 sine squared theta, and using the fact that cosine 2 theta is 1 minus 2 sine squared theta, rearranging that to complete the proof as required. So this gets you your final 2 marks. We have been told, hence, solve for minus pi over 2 to pi over 2 for x, the equation secant squared x minus 5 times 1 minus cosine 2x equals 3 tan squared x sine 2x. And we are told, give any non-exact answer to 3 decimal places where appropriate for 6 marks. Okay? So first, I'm going to highlight the domain over which x is valid for. Okay? Like this. And I'm also going to highlight that we need to give any non-exact answers to 3 decimal places. Okay? So what we need to do is we need to look at the equation we've been given and try and manipulate it using this identity that we worked out in part A. Okay, so the first thing we're going to do is I'm actually going to take tan squared sine 2x and I'm going to split it up. So I'm going to say that secant squared x minus 5 times 1 minus cosine of 2x equals 3 tan x times, and then we have tan x sine 2x, like that. Okay, now what we can do is we can use our identity. So I'm just going to show that we're plugging this into here. Okay, so what we would end up with is secant squared x minus 5 times 1 minus cosine of 2x equals 3 tan x, and then 1 minus cosine 2x. 1 minus cosine 2x. Like that. Okay? The next step I'm going to do is I am going to bring both sides, the right hand side over to the left, okay? So what we'll end up with is secant squared x minus 5 times 1 minus cosine 2x minus 3 tan x 1 minus cosine 2x equals 0. What I'm then going to do is I'm going to take out 1 minus cosine 2x out as a factor, okay? So we will end up with 1 minus cosine 2x and then times secant squared x minus 5 and then minus 3 tan x. Okay, just put the square bracket equals 0. Okay, so just in conclusion, what I've done is I've taken 3 tan x times 1 minus cosine 2x, moved it to the other side, and then taken 1 minus cosine 2x out as a factor to leave secant squared x minus 5 minus 3 tan x. Okay. Now, what I'm going to do here is I'm going to introduce another step, and I'm going to use the identity that secant squared x equals 1 plus tan squared x, okay? And the reason I'm going to use this is because we are going to say that using this, we get that secant squared x minus 5 equals, so it's going to be tan squared x plus 1 minus 5. So this is going to be tan squared x minus 4, okay? So tan squared x minus 4. I'm going to plug this for our secant squared minus 5. So what we will end up with is 1 minus cosine 2x times, let's just fix the bracket sign, times, so we've got tan squared x minus 4 and then minus 3 tan x, okay, equals 0. Alright, now at this point we have two products which equal 0, which means either 1 minus cosine 2x is 0 or tan squared x minus 4 minus 3 tan x equals 0. Okay, so let's write this down. What we can say is 1 minus cosine 2x equals 0, cosine 2x equals 1. This means that 2x equals the inverse cosine of 1, which is 0, and therefore x equals 0. Now, before we can say x equals 0 and move on, we need to check if it's a valid solution, okay? So, our question said, solve for x between minus pi over 2 to pi over 2. 0 is between there, okay? So this is valid. So I'm just going to write in brackets here, valid, okay? The next step is to solve when tan squared x minus 3 tan x minus 4 equals 0. And the reason I've written it like this is because this is actually a quadratic in terms of tan x, okay? What we can do is we can do a substitution and say let lambda equal tan x. So this becomes lambda squared minus 3 lambda minus 4 equals 0. And the reason I've done this is because now it's in a more familiar form, okay? So usually you're dealing with x squared minus something in terms of x plus a constant. Here we've just substituted lambda, but still you can see the resemblance, okay? It's much more comfortable to work with than just in terms of tan x, okay? From here, what I'm going to say is that we have lambda minus 4 and lambda plus 1, okay? Just checking, minus 4 times 1 gets us minus 4, so that's good. And then minus 4 plus 1 gets us minus 3, so that's good. So this equals 0. And then this means that lambda equals 4, or lambda equals minus 1. From here, because we know that lambda equals tan x, we can say therefore tan x equals 4, or tan x equals minus 1. When tan x equals 4, this means that x equals the inverse tan of 4, and the inverse tan of 4, if you put it into your calculator, you would get 1.3258, etc. And then the inverse tan of minus 1 is minus pi over 4, okay? So minus pi over 4 like that, okay? Again, like we did with x equals 0, we need to check that our x values are valid. So 1.3258, is it in between minus pi over 2 and pi over 2? Well, if you check what pi over 2 is, you will see that it is. So this one is also valid. Okay, and minus pi over 4 is again in between there, so this is also valid. Okay, so now what we need to say is solutions are x equals 0. Now remember, for x equals 1.3258, because it's not an exact value, we were told to round it to 3 decimal places. Okay, and that is exactly what we're going to do. We're going to say this rounds to x equals 1.326, and then finally we have x equals minus pi over 4. Okay, so that is 3 solutions for our equation. So this question is worth 6 marks. Your first mark comes from doing the work to get that x equals 0 as the first solution. Your second mark comes from using secant squared x equals 1 plus tan squared x, substituting that for secant squared x minus 5, and by extent getting that this here equals 0, so 1 minus cosine 2x times tan squared x minus 4 minus 3 tan x, so that. Your third mark comes from knowing that tan squared x minus 3 tan x minus 4 equals 0. Your fourth mark comes from factorizing tan x correctly, so getting tan x or lambda either way equals 4, and it equals minus 1, so this will get us here our fourth mark. And then our fifth and sixth mark come from getting the final 2 correct solutions, so this will be 1.326 and x equals minus pi over 4. We are told figure 2 shows a sketch of part of the curve C with equation y equals x ln x. Okay, so let's pick that out. The line L is the normal to C at the point P, which has coordinates EE. So line L is a normal to C, and then at this point. The region R, shown, shaded in figure 2, is bounded by the curve C, the line L, and the x-axis. And we have been asked to show that the exact area of R is AE squared plus B, where A and B are rational numbers to be found. And this question is worth 10 marks. The first thing I'm going to do is I'm going to annotate figure 2 by drawing a vertical line from point P to our x-axis. The reason I've done this is because now we've split our area, our shaded region R, into 2 smaller shaded regions, R1 and R2. R1 is the area underneath the curve, so underneath curve C, okay, and R2 is this right angle triangle, which is going to make finding it easier, the area much simpler, okay. The other point I'm going to pick out on is because we have drawn a vertical line down, it means the point at which these 2 regions intersect is E, okay, like that. So what we need to do now is we need to find the equation of line L, okay, so what we say, finding equation of line L, like this, okay. So the way we're going to do this first is we're going to use the fact that L is a normal to C to find the gradient of L. So what we're going to say is, since line L is a normal to C at P, this means that our gradient of line L at P equals minus 1 over our gradient of the tangent to C at point P, okay? And in doing so, I'm actually just going to write that down, all right? So I'm going to write that ML, which is the gradient of the line, this is the gradient of L at P. So gradient of L at P. And MT equals gradient of tangent to C at P, okay? The only part we can find right now is MT, so what we will say is that we will look for MT. Now MT, being the gradient of the tangent to C at P, this is going to be dy by dx at x equals A. So the gradient dy by dx the gradient, of the tangent to C, which is dy by dx at x equals A, which is at point P. Okay, so that's how that works. So now we will say dy by dx equals d by dx of x ln x, like that, okay? Because that is the equation of our curve C. To find this, what we need to do is we need to use a product rule. And the product rule says that dy by dx will be the first function times the derivative of the second function plus the second function times the derivative of the first function. So it will be x times d by dx of ln x plus ln x times d by dx of x. This equals the derivative of ln x with respect to x is 1 over x. So we have x times 1 over x, which is 1. And then the derivative of x with respect to x is 1. So we have plus ln x, like that. Okay? What we then say is this means that mt equals dy by dx at x equals a. So it equals 1 plus ln of a, which is 1 plus 1, which equals 2. Okay, so we can just say mt equals 2. Now we can say, because ml equals minus 1 over mt, that it equals minus a half. And then from here, we can use the fact, so we say using y minus y1 equals the gradient of L times x minus x1 to find L, okay? And we know that y1 equals a and x1 equals e, because we've been told this in the question. This is the point P, okay? So I'm just going to write in brackets point P. From here, what we will say is that y minus a equals minus a half, which is our gradient of L, times x minus a, like that. Coming down to the next page, we can rearrange this to say that y equals a minus half x plus half a. From here, what we can actually do is we can rearrange these and sum these. So we can say that, therefore, y equals minus half x plus 3 over 2a. Okay, so I'm going to come back to our diagram and add this. So we're going to say that y equals minus half x plus 3 over 2a, like that. Now we found L and we know our equation of C. What we can actually do is we can look and start solving the question. So to find the area under the curve, we actually need to know the x-coordinate where our curves intersect the x-axis, okay? So we're going to start by finding L because we're already working with it. And what I'm going to say is that because at the x-axis, y equals 0, we're going to solve when minus a half x plus 3 over 2a equals 0 to get to this point here, okay? So what I'm going to say is finding where L intersects x-axis. Okay, so to do this, we're going to use the fact, like as we said, that at x-axis y equals 0, and then we're going to come with that minus half x plus 3 over 2e equals 0. This means that half x equals 3 over 2e, and this means that x equals 3a, okay? So that's the point, that's the x-coordinate of where the line L intersects the x-axis, which is 3e, like that. The final step is to find where curve C intersects the x-axis, okay? So what we're going to say is finding where C intersects x-axis. And then again, because at x-axis y equals 0, we can say that x ln x equals 0. From here, we have two solutions. We can say x equals 0 or ln x equals 0. And for ln x to equal 0, this needs to, what this means is that x has to equal 1, okay? So we say that this implies x equals 1, all right? Coming back to our diagram again, we're going to draw on our final two solutions. So we have 0 and 1 here, okay? Now we can actually start finding the area. So the first thing I'm going to do is I'm going to find the area of R1 because that comes before R2, okay? R1 is the area under the curve C, okay, between, so C, the x-axis, and this vertical line here, okay? So we're going to be integrating curve C between 1 and A, all right? So what we're going to write is we're going to say area R1 equals the integral from 1 to A, so of our curve C, which is x ln x with respect to x. To integrate x ln x, we need to use integration by parts. And integration by parts tells us that if we have the integral of u dv by dx with respect to x, this equals uv minus the integral of v du by dx, like that, okay? And then, sorry, with respect to x at the end. So what we need to do now is we need to pick a u and we need to pick a dv by dx, okay? The common rule here to picking u and dv by dx is you pick for u whichever would be hardest to integrate, okay? So let's look, integrating x, well, that's easy, that's x squared over 2. But integrating ln x, well, to do that, you'd have to go into a second instance of integration by parts. So because ln x is the hardest to integrate, you would pick it for u to differentiate. So u equals ln x, and that leaves dv by dx equals x. This means du by dx equals 1 over x, and that v equals x squared over 2. Now, what we are going to do is we are going to apply our formula here. So what we will say is that this equals, so uv is x squared over 2 ln x, like that. I've actually done vu, but it's neater to write it this way, and it's the way the Marxium has laid it out, which is why I've copied that, okay? Again, from using our limits, e to 1, minus the integral from 1 to a. So it is going to be v du by dx. So v is x squared over 2, and then du by dx is 1 over x. So it's going to be x squared over 2 times 1 over x with respect to x, like that, okay? Next step, x squared over 2 ln x. Using our limits of integration, and then this is going to be minus, now x squared over 2 times 1 over x is the same as x over 2, so all we're doing is integrating x over 2. So the integral of x over 2 with respect to x is x squared over 4, so this is going to be minus x squared, let's just make that a bit neater, x squared over 4 from e to 1, like that, okay? So all we need to do now is plug in e and 1 for each of our parts and then simplify it, okay? So what we'll end up with is that this equals e squared over 2 ln e, okay, minus e squared over, 1 squared over 2 ln of 1, close our brackets, minus, now open our brackets again, e squared over 4, minus 1 squared over 4, okay? Like that. So from here, what we can do now is we can start evaluating stuff. So e squared over 2 times ln e. Well, ln e is just 1, okay? So this is just going to be e squared over 2. Now, ln 1 in this part here, ln 1 is 0, okay? So this is 0. And this means that this entire term becomes 0 and cancels out, okay? So what we're left with is e squared over 2, and then we've got a minus e squared over 4, and then we have plus 1 over 4, like that, okay? E squared over 2 is the same as 2e squared over 4, so 2e squared over 4 minus e squared over 4 is e squared over 4 plus 1 over 4, like that, okay? So now we have found the area R1. The next step is to find the area of R2 equals. Coming back to our diagram, area R2 is a right angle triangle, okay? Now the base is between E and 3A, okay? So the base will be 3E minus A, and our height will be A, okay? Because look here, how we've been told that this point, I'm just going to draw it now, here, okay, this point here is in fact A as well. So it's a height of A and it's a base of 2A, okay? So we're going to say that the area equals half times 3A minus A, which is our base, times A, which is our height. This gets us half times 2A times A, which equals A squared, like that, okay? Final step is to say that area R equals R1 plus R2. We said that R1, if we come back, was E squared over 4 plus 1 over 4. So this is E squared over 4 plus 1 over 4. And R2 is just E squared, like this. So what we now have is we have E squared over 4 plus 1 over 4 plus 4E squared over 4. And this means that we get 5E squared over 4 plus 1 over 4, like that. And here I'll just add that A equals 5 over 4 and B equals 1 over 4, like that. Okay, because they did say A and B are rational numbers to be found. So we found them and we've shown them explicitly. So this question is worth 10 marks. Your first 2 marks come from getting that dy by dx equals 1 plus ln x. Your third mark comes from using the information to get the equation for L and to show some attempt of solving for x when y equals 0. Your fourth mark comes from getting that x equals 3e when L meets the x-axis. Your fifth mark comes from either attempting to solve the integral or the area of the triangle for the shaded region. Your sixth mark comes from doing integration by parts to solve x ln x to get this line. Your seventh and eighth mark comes from correctly evaluating that to get half x squared ln x minus a quarter x squared. Your ninth mark comes from finding your other area and correctly getting the area R1 and R2 and knowing that the final area is the sum of those, and your 10th mark comes from getting the correct final area of 5 over 4 e squared plus 1 over 4. We are told a scientist is studying a population of mice on an island. The number of mice n in the population, t months after the start of the study, is modeled by the equation n equals 900 over 3 plus 7e to the power of minus 0.25 times t, where t is a real number and t is greater than or equal to 0. Partey has asked us to find the number of mice in the population at the start of the study for 1 mark. Okay, so I'm just going to highlight some key parts. Okay, so the number of mice is n. T months is the time after the start of the study. Okay, I'm also going to highlight the equation which is being used to model it, and I'm going to highlight that we need to find the number of mice in the population at the start of the study. Okay, when you're told at the start of something, this usually means t equals, actually always means that t equals 0. So what we need to do is we need to plug in t equals 0 for our equation. Okay, so we're going to say n at start, okay, equals 900 over 3 plus 7 e to the minus 0.25 times 0, okay? This equals 900 over, so e to the minus 0.25 times 0. So it's going to be e to the power of 0, which is going to be 1. So it's going to be 3 plus 7 times 1, which is just going to be 10. So 10, and then this equals 90. You get 1 mark for this question, and that 1 mark comes from getting a starting population of 90. Part B says, show that the rate of growth dm by dt is given by dm by dt equals n times 300 minus n all over 1200 for 4 marks. Okay? So what we're going to do is I'm first going to rewrite n without the fraction components. I'm going to say that n equals 900 times 3 plus 7e to the minus 0.25t, and then all of this to the power of minus 1. Okay? The next step is I'm going to use the chain rule. So the chain rule says if you have y equals a function of another function of t, so y say just f gt, like this, what this means is that you can rewrite y as y equals a function of u, and then you can say that u is a function of t, And then in turn, dy by dx will equal the derivative of the function of u times the derivative of the function of g, and then what you will end up doing is you will be replacing u with whatever your function of gt was. Okay, so what I'm going to do is I'm going to say n equals 900 u to the minus 1, and I'm going to say u equals 3 plus 7e to the minus 0.25t. Okay, I'm going to say dn by du equals minus 900 times u to the minus 2. That's basic differentiation. And then I'm going to say du by dt equals, so 3 differentiates to 0, and then you have 7e to the minus 0.25t. What you would do is you bring this minus 0.25 in front of the exponent, so you would get minus 0.25 times 7 times e to the minus 0.25t, like that. Okay, so from here what we can say is dn by dt equals, so we have this minus 900, and then because we have 0, minus 0.25, etc., we can cancel this 0, and we're just left with minus 900 times minus 0.25 times the rest. So it's going to be 900 times 0.25 times 7e to the minus 0.25t times u to the minus 2. But we know that u is 3 plus 7e to the minus 0.25t. So this is going to be times 3 plus 7e to the minus 0.25t, all to the power of minus 2, sorry. Okay? Now, what I'm going to do is I'm going to replace all the instances of t to write them in terms of n, okay? Because our final differential is given in terms of n. So because we know that n equals 900 over, so I'm just going to actually do that, over 3 plus 7e to the minus 0.25t. Okay, we know that 3 plus 7e to the minus 0.25t equals 900 over n, and by extent 7e to the minus 0.25t equals 900 over n minus 3. Okay, from here what we can do is we can plug in 900 over n into here, and we can plug in 900 over n minus 3 into here. So what we'll end up with is dn by dt equals 900, now 0.25 is 1 over 4, so it's going to be 900 over 4 times 7e to the minus 0.25t. We said that is going to be 900 over n minus 3, and then times, now we have 900 over n to the power of minus 2. But what we can say actually is we can say that this is n over 900 to the power of 2, because the minus will invert the fraction. So we'll just end up with n squared over 900 squared, like that. Okay? From here, what we can do is, because this sort of resembles the 300 minus n form we need, okay, because we've got 900, n, and 3. What I'm going to do is I'm going to take out a factor of 3 over n, okay, so this is going to be 900 over 4 times 3 over n, and then in brackets, it's going to be 300 minus n. And the reason is because the 3 is taken out as a factor, so you have 900 divided by 3, which gets you 300, and then you have minus 3 divided by 3, which gets you minus 1. But since you're dividing by n, you have 1 over n, so you take that as a factor, but then because you have 1 over 1 over n, which is just n. So that gets us like that, okay? And then this is going to be times n squared over 900 squared, okay? What I'm going to do now is I'm going to start cancelling terms. So this 900 squared and 900 cancel, so all you're left with is 900. This n and this n squared cancel, so all you're left with is n. And then this 3 and this 900 again cancel, so all you're left with is 300. Okay? So, in conclusion, what you'll be left with is this equals n over 300 times 1 over 4 times 300 minus n. And then just to finish it, we can say therefore dn by dt equals n times 300 minus n all over 300 times 4 is 1200, like that. So this question is worth 4 marks. Your first 2 marks come from correctly doing the chain rule to get this line. Your third mark comes from substituting any instance of 7e to the minus 0.25t with this correct form of n, so what we have done up to here. And then your fourth and final mark comes from doing the correct algebra to get the final answer as we have down here. Part C has told us the rate of growth is a maximum after t months. Find, according to the model, the value of t for 4 marks. So when it says anything is a maximum, okay, after t months, what it is looking at is it's looking that dn by dt equals 0. Okay, so what we need to do is we need to look at the graph for when dn by dt is 0. So this means we need to look for when n times 300 minus n equals 0. Alright, so if I was to draw the graph, okay, which looks something a bit like this, it's a negative quadratic, like that, okay, we say that this is 0 and this is 300. This axis is n and this axis is dn by dt. Okay, so just checking it makes sense. When dn by dt is 0, so that means here n is 0 and then so that's all correct. Okay, now what we need to look for is when dn by dt is a maximum, and it's a maximum at here. Okay, and because this is a parabola, it is symmetric between the two roots, so this is going to be 150. Okay, so it means that dn by dt is a maximum at n equals 150. So we can just write that dn by dt is maximum at n equals 150. Alright? From here, what we can do is we can plug in n equals 150 into our equation. Okay? So what we're going to say is 150 equals 900 over 3 plus 7e to the minus 0.25. Now be careful here, we've been told to use capital T, okay? So that's the one I'm going to use. So it's going to be capital T like that, okay? Rearranging this, so this means 3 plus 7e to the minus 0.25 capital T equals 900 over 150, which is 6, so equals 6. Then we have 7e to the minus 0.25 capital T equals 3. E to the minus 0.25t equals 3 over 7. Minus 0.25 capital T is ln of 3 over 7. Okay, and this means that t equals ln 3 over 7 times minus 4. Okay, so if you were to put this into your calculator, you would get a time frame of that t equals 3.38 etc. months. I'm going to round it to 3.4 months. Okay, so it's to say that therefore t equals 3.4 months, like that. Okay. This question is worth 4 marks. Your first mark comes from showing that n equals 150. Your second mark comes from getting that e to the minus 0.25t equals 3 over 7. Your third and fourth mark comes from doing the correct rearranging, and here you can have either that t equals minus 4 times ln 3 over 7 or that t equals 3.4 months. Either one gets you both of your final marks. We have been told, according to the model, the maximum number of mice on the island is p. Part D has asked us to state the value of p for 1 mark. Okay? If you were to look at the graph of this equation, okay, so you were just to plot it or to sketch it, okay, what you would notice is that it increases forever. Okay? So I'm just going to draw it, and it goes up something like this. Okay? What this means is, it means as the time gets extremely large, the model won't end up reducing or won't end up decreasing the number of mice. So the number of mice will constantly grow. Sorry, if this is t and this is n. Okay? So when it says what is a maximum number of mice, okay, what you are able to assume is that this is taken into account as t approaches infinity. Okay, actually I'm probably just going to change the color. So as t is approaching infinity. Okay, so when t approaches infinity, what we can say is that as t approaches infinity, 0.25t also approaches infinity, meaning that minus 0.25t approaches minus infinity, and that e to the minus 0.25t would approach 0. Okay? Because remember, minus infinity, so as the number gets smaller and smaller and smaller and smaller and smaller, it will become 1 over a very, very, very large number. So that's going to be 0. So it's going to approach 0. Okay? From here, what you can say is, this means that P equals 900 over 3 plus 7 times 0, which is 900 over 3, which equals 300. And for this question, you get 1 mark, and that comes from getting 300 as your final answer.